The displacement in meters of a particle moving in a straight line is given by this function. So the displacement S is written in terms of t by this formula, where t is measured in seconds. In part A, we are asked to find the average velocity over each time interval. So there are 4 questions. So need to find average velocity. In part B, we are asked to find the instantaneous velocity, or just the velocity. Okay, and we know that when we have a function, let's say st, and over an interval ab, the average velocity is same as the slope of secant line. So that will be, we have, let's say this is a position or the displacement, and av is time interval. So here is the displacement, here is the displacement, and here is the displacement at a. And if we join this, so this is rise, this is run, and that gives average velocity. So that will be rise means AB means evaluate S at B minus SA, run means B minus A. So these are AB for each question. So we're going to use this 4 times here. Okay, just for A. Then instantaneous velocity means just the derivative, okay, slope, rate of change. So let's do this for A. On 2, 3, the average velocity will be just S3 minus S2 over 3 minus 2. Now evaluate this function at 3 using your calculator. Evaluate at 3 means just 3 square minus 4 times 3 plus 8. Okay, that comes out to be 5 minus S2, just do the same thing, over 4, 3 minus 2 is 1, and that's just 1 meter per second. Okay, you can just graph this function on your calculator and just do the table to figure out these or evaluate. That's over 2.5 and 3, S3 minus S2.5 over just 3 minus 2.5. S3 is 5 minus, evaluate this function at 2.5, that comes out to be 4.25 over 0.5. Now use your calculator, just divide 5, subtract and divide by 0.5, it comes out to be 1.5 over this interval 4, 3. So AB, so S3 minus S4 over 3 minus 4. This is 5 minus S4. Evaluate at 4. That's 8 over negative 1. Negative 3 over negative 1, just 3 meters per second. And the last, S3 minus S3.5 over 3 minus 3.5, that's 5 minus, evaluate this, 6.25 over 3 minus 3.5 minus 0.5, that is 2.5 meters per second. Okay, we answer all this. If you look at this closely, so we found the average velocity over 2, 3. In the next we found 2.53. The next is 2.53. So we are going closer to 3. On the other hand, in part 3 and 4, we did 4, 3, then 3.53. Okay, and 1.5. When we do here, that's 1, then go closer to 3, we got 1.5, 1, 1.5. So increasing. From the right side, it's the 3, 2.5. So it's a decreasing. So 1, 1.5, here 3, then decreasing 2.5. We can kind of guess this 1, 1.5, maybe 2, 3, 3.25. Sorry, 3, 2. Mistake here, it's a 2.5. And it's going to us 2. That could be instantaneous velocity. So, but we cannot go in this way. If you want to do this, then we need to go really close to 3, not 2.5. We need to go maybe 2.999. Here, not 3.5, 3.001, something like that. So let's find instantaneous velocity of this function at t equals 3. So part B. So the displacement is given, yes, but is given in terms of t square minus 4t plus 8. And we want to find at 3. Okay, instantaneous velocity at 3. Now that is same as slope of tangent line at 3. So this is same as slope of tangent line at 3. And we have the formula. Slope of a number a is just f prime a equals just a function. What is the formula? That the f of x plus a minus f, my bad, it's not the correct formula, limit of f of a plus h minus f of a over h, as h goes to very small. But our function is s and a is 3. So the instantaneous velocity will be s prime at t equals 3. So I'm going to write not t at 3 is limit h going to 0 of the function a plus h, where a is 3, minus the function at 3. Okay, this is just the modified for our case, and now we're going to evaluate this limit and we got the answer. So this is limit h going to 0 of minus s of 3. I mean, we've done several times s of 3 using our calculator. That came out to be 5, or here as well, it's 5. So this one is 5, but s of 3 plus h, now that's not a number because we have h. So s of, look at this input, s of input is square minus 4 times, this is input square minus 4 times input plus 8. That's the s of input. Our input happens to be 3 plus h here. So we need to replace this t by 3 plus h. So let me do on side here. So it's a lot of algebra. So s of 3 plus h is from this function t square, means this input is square, 3 plus h is square minus 40 minus 4 times 3 plus h plus 8. Let's simplify. 3 plus h square is 3 plus h times itself. Just multiply. It comes out to be 9 plus 6h plus h square. Here is minus. Now distribute. Okay, 12 minus 4h plus 8 equals, now let's combine 9 plus 8, or h square 9 plus 8 17 6h minus 4h plus 2h 9 8 17 minus 12. Okay, 9 plus 8 17. So we got h square plus 2h plus 5. H square plus 2h plus 5 here. Okay, with this, now let's simplify the top. Here on the top we can see plus 5 minus 5 just 0. Okay, and that leaves limit h going to 0 of h square plus 2h. Now we can factor h so that we can cancel h plus 2, then h cancel. Okay, now we're going to plug in h0 into this function. So 0 plus 2, which is 2, just 2. So that's the velocity, so 2 meters per second, and that's what we expected earlier. Final